Hi, in this video I'm going to be going over the idea of Lagrange multipliers. So here we have a function of two variables, f of x and y is equal to x squared minus y squared, which is the function of a hyperbola. And this function is subject to the constraint x squared plus y squared is equal to 4. And this is an equation of a circle of radius 2. So first let's draw level curves for the function. So the way we draw level curves is you set the function to a constant and then you sketch the equation. So by setting the function to 0, you get 0 is equal to x squared minus y squared, and when you sketch it you get these two straight lines over here. F of 1, so when you set the function equals to 1, you're gonna get these two curves. So f is equal to 1. When you do f is equal to 4, you're gonna get, so f is equal to 4, f is equal to 4. Also, when you set f is equal to negative 1, you get these two curves, this one. You set f is equal to negative 4, and so on. Okay. Now let's sketch the constraint we have, which is a circle of radius 2. By the way, this point here is 2. This point here is 2. Sorry, this is negative 2. This is 2. And this is negative 2. Okay, so when we sketch the circle, again it's a circle of radius 2, so it's gonna look something like this. And we are constrained to only move along this path over here. Now if I ask you to find the maximum and the lowest value of the function subject to this constraint, so the way you can think about it is you have the level curves, so you see what's gonna be the highest value that lies on this circle over here, and you can see that the highest value you can get is 4. So you get the value 4 when you're at this point over here. Let me try a different color. You get 4 here because all the points lying on this curve have a value of 4, and since we're constrained to be moving along the circle, this is the point where we're gonna get the highest value. You get the lowest value at these 2 points, so here the value is negative 4, right? Okay, so now let's draw the gradient of the function. Remember, the gradient of the function always points to the direction of steepest increase and is always perpendicular to the level curves. So at this point, if I want to draw the gradient, it's going to be perpendicular to the level curve, and it's going to be pointing to the direction of steepest increase, which is going to be this direction. Same it here, here, and so on. This section is going to be here, right? Okay. Now let's draw the gradient of the constraint. So again, it's going to be perpendicular to the level curves and is pointing to the direction of steepest increase. So this here is an equation of a circle. So the direction of steepest increase will be radially outwards, because if we have other circles with like another circle with a bigger radius is going to be lying outwards, so it's going to be pointing radially outwards. The gradient is pointing radially outwards, and again it's perpendicular to the level curve, so here and so on, right? So something interesting happens here is you see that you get the maximum and the minimum points, or the highest and lowest values of the function here, here. So you get these points when the gradient of the function was parallel to the gradient of the constraint, right? And remember, these are two vectors, so we can rewrite this by the gradient of the function is equal to some scalar multiplied by the gradient of the constraint. And that's the way you find the maximum and minimum points using the Lagrange multipliers. You find the gradient of your function, the gradient of your constraint, and you say that the gradient of your function is equal to some scalar or some number multiplied by the gradient of your constraint. And we call this over here the Lagrange multiplier. And that's the basic idea of Lagrange multipliers. So if you have any questions, please leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.